Hi there, this is Kilton from IOTRACKS and welcome. So the goal of this video is for you to get an understanding of the entire IOTRACKS architecture and you know, we don't have a 20-second cartoon explainer video. I believe that our budget is better used elsewhere. And so if you really want a cartoon of like a rocket and a cloud and whatever, then you can just write to me. Otherwise, this is what you get. So IOTRACKS, open source fog computing. Why? Well, computing is not actually commoditized. I think that it was more commoditized at one point. We had you could choose from Mac or Windows or various flavors of Linux or Unix, and you pretty much used computing in certain stacks, and you could deploy it and scale it and whatever, and put software on top of it, and then you didn't think that much about it. But we're in a different era now. So what's happened is that we have a bigger proliferation of microprocessors now than we've had in a long time, and a lot of them are very tiny. And so we have different computing happening at different levels. In a data center, you might have largely in-memory processing taking place for large amounts of data that's changing in real time. That's not the same computing that you need when you're actually talking to a handful of sensors in a secure environment, and they need to run on batteries, right? So, okay, different computing, different layers. Well, IOTRACKS tackles this challenging problem of where the computing happens after the generation. So let's call this a device. After the generation of data, and this is the big question mark here, solved by IOTRACKS, but before the end consumption or use of that data. This is a mobile phone. This is some cloud processing, cloud service that's taking place and making that, hosting that on some web application out to browsers everywhere. And then maybe this is a big data style application that is making use of it in some back center there. So what happens here? This is what we're focused on, and that's what I'm going to talk to you about. So how does this happen? Well, we've got this thing called IO Fabric. So you take any computing that fits the bill, which right now, let's say this is a 1U Linux box. And then let's say that this is a Raspberry Pi, and that's also Linux, right? And then let's say that this is perhaps like just pick another board. This is a Samsung Arctic, which also runs Linux, and these are small boards there. So you want to be able to do computing in a way that fits for your actual solution. And that's where it needs to be abstracted, and that's why we have this open source fog computing. So IO Fabric is the software that gets installed on all of these things. And so in the near future, you will also see IO Fabric being installable on things like iPhones and iPads and maybe some Android devices, which, according to iconography, look almost identical to iPhones, at least with my handwriting. And so the fabric gets installed across everything that you want to be able to instantiate dynamically different computing upon. And so this, in essence, becomes what we would call the compute fabric, or the fog computing layer. And you have then some control of it, which takes place here. And what's underneath it is what really matters. Why did you deploy IO Fabric to the various compute instances that you chose? If you're using Raspberry Pi or some other IoT-oriented board, you probably have some sensors that are out there in the field somewhere, and you want to talk to them. And maybe then you've got a camera, and this camera is on a little stand, and then this camera is connected on, via TCP/IP, and then maybe these guys are wireless. So then, use Raspberry Pi because that's got a great little Bluetooth radio in the Raspberry Pi 3, and so you're using that to talk to these devices. Over here in your 1U Linux box, you probably have something more along the lines of, let's say, an old LDAP, server, or LDAP/Active Directory, and you want to use that stuff that's on the LAN, and then maybe you also have some cameras here, and you want to tap into that. There's many more of them than this circumstance, and all of them are networked in. And so you can think of this as a really good LAN situation. Okay, that's the reason why you chose to put IOFabric on all of these. Now, what does IOFabric give you? Well, so it's open, so you can go out there and look at the repository and check out the documentation there of how IOFabric works. I'm just going to talk about what IOFabric does architecturally here. So you have a box, and you put IOFabric on it. Now, it's down here, and it has all of the outputs that that box is capable of having. If it has Bluetooth, then you get Bluetooth. If it has connection to the LAN, RJ45 jack, then you get connection to the LAN. And all of the different outputs are available to you. And then you have now, since you've installed the IOFabric, you have space to instantiate dynamically any processes that you wish. These are microservices. I'm not going to write that in there, I'm just going to shortcut it. Where do the microservices come from, and why are you using this methodology? Well, if you've got a whole bunch of devices down here of varying shapes and sizes and languages and protocols and connectivity types and so on, you need to run different software against it. If these devices are so heavy, so capable, that you can actually write and embed code on them, then you probably should. But unfortunately, we don't live in a world where $80, $90 devices that require a provisioning and programming process are really the norm. There's a lot of new stuff coming out that enables you to do that. This is what we're doing today. This is a brand new device, and let's just say, for the sake of being fair, it's a $30 device, right, which is also still too expensive. But then it needs a little bit of labor, right? So, you can do the math on adding some labor cost into there. This thing gets programmed, and you connect it via USB cable or whatever, and this is, what you've written custom software for. And this thing needs to get connected to the Wi-Fi, so it's got a Wi-Fi transceiver on it there, and then it's got, you put it in some environment where there's Wi-Fi, and then through that Wi-Fi and so on, it talks all the way up to some cloud where you've set up a backend so that you can receive it. Or you've bought a board that lets you do all of this, and then you've got somebody's backend cloud, some company that you bought the board from, and then you tap into their cloud, and essentially they charge you for, or rather they are doing all of the infrastructure for you. This brings tears to my eyes. As soon as you leave the edge environment here and go straight up to the cloud, you have all kinds of losses. That's why you care about doing compute right where the devices are. You have increased latency, so you lose speed. You lose privacy and security. You just have the bandwidth expense, and then if you have to pay for anything on this back-end infrastructure, or you own the infrastructure and have to scale it, you're storing all kinds of data that could have been processed at the edge. So I'm not going to make a case for edge computing. If you don't understand the value of that, you've probably never built anything with this, because if you have, you know right away that this covers some great use cases, but it's not everything. So back to this. You have some sensors you want to talk to. Wouldn't it be great if you could have the computing available and choose the microservice that you wanted in order to match with whatever it is that you have just deployed into this environment? And then we'll call this one C. I shouldn't have written microservice in there. And let's say then you decide that you no longer want to run device C in your solution because C costs $200 and one just came out from some great startup company. And what shape should I make this? How about this? And this thing is D, and this thing costs 1/10 of the price, and you love it, and it's super stable, and so on. Wouldn't you rather trade out C for D right there in your deployed environment and begin now to talk to this new sensor? Yes, you would. That's why we're doing this. That says bad. That's not good. Let's change that to E. I don't want you to get the wrong impression. So anyway, you would love to do this, but the trick with that is then you would have to have some kind of commoditized compute where you could treat it all the same, or abstracted, I should say, and that is why you've put IOFabric on there. So what's it like to create these and write these? So these are microservices, and the microservices are just a matter of encapsulating code inside a container package. And you get any language here. I really mean that. So that's a big plus, I think. And any framework as well. So you write the code, and then you encapsulate it. Docker is the containerization that is currently used in IO Fabric that's available for download today. And the reason that we do this is so without a containerization mechanism, you would be compiling against a particular SDK, or you would be writing in particular languages that fit on a certain gateway. If this is a an edge gateway here, you would be maybe this thing speaks C++ and maybe it speaks Java, and then you say, okay, those are the two things they allow me to do. I'll write in those languages, and then let me get the IT guy to flash this gateway with my code, and then we'll deploy it, and then this can talk to A, B, and C, and D, and but not BAD, and E, and that's how you would do it. And then you would focus on the deploy being an IT operation, and then the programming as being something that was pre-planned. I think this is absolutely terrible, and it doesn't scale. What you want to be able to do is what I've described. And so you pick a language and you say, I like, let's say, for example, Python. And so you write this thing in Python. And then after you finish your code, you encapsulate. And that is just a matter of wrapping it with, you use a Docker file, and then you build a container. And this gives you access to all of your frameworks. And this gives you access to your choice of Linux that underlies it, etc. All of these are the advantages of containerization. Without this mechanism, it really wouldn't be possible to let programmers do what they do best, which is pick everything that makes the right circumstance for writing the best code to work against sensors or to work against just flowing data. So this is an open microservice opportunity. And then the IO Fabric allows you to instantiate them, as I showed you. Therefore, you can run any code in any language, anywhere that you have deployed the IO Fabric. Okay, this is good stuff. You gain so much from this. So you get this code reuse, and that allows you to say, I wrote something for sensor A, and then over here I have another installed IO Fabric, and we were using it here with sensors, a lot of A sensors. There's a ton of them here, and this is all working well. Well, over here we used to have B sensors, but now we deployed A sensors over here. I can instantiate the same microservice, which is a container, at the click of a button, and start using it in this location. This is location number 2. This is location number 1. Great code reuse. Who wrote these? Either they're written by the manufacturer of the sensors, they're written by IOTRACKS or someone who is in the IOTRACKS development community who really cares about working with these sensors, or they're written by the development team that normally would have written some hard-coded thing, the software that they would have pushed to some edge gateway via deploy process or whatever. That's how this can all happen. Okay, so that's something that you get right from there. Let's also talk about what happens with the interconnectivity of these, and then we are talking code reuse. So code reuse is also a matter of dynamic configuration. So let's take a look at here, and then you've got instantiated these couple of microservices that you wrote, and then let's say these are FGH. Okay. So H is supposed to talk to this this server that's on the LAN, and so this compute box that's got IO Fabric is on the LAN, and so it can talk to just about anything you give it access to, and and then let's say this is Active Directory, and you want to talk to this, you want to find out some stuff about the people that are actually working in the environment. So how does this thing? How does the containerized process that is H, the microservice that you wrote, get any information? So there's this thing called a fabric controller. And the fabric controller is what tells all of the IO fabrics across the entire globe what it is that they should be working on. And that is pretty much all there is to that. There's a little bit of magic here. And but the fabric controller has some configuration that was created After you chose to instantiate the microservice H on this piece of the fabric, you also specified some configuration for H. And this gets delivered down via the connection between the fabric controller and the fabric node, and H gets its config. That means that when you wrote H, you should probably have written H to get config dynamically at runtime, otherwise you wrote a very limited and non-reusable H. Let's assume that you followed the instructions and you actually thought about reusing H everywhere. You then get different instances of H have different instances of config that come down. This allows you to say, I'm going to get a microservice in place for a common thing that I do in my entire solution, deploy it everywhere it needs to be deployed, and give it dynamic configuration that varies for the particular situation where it's being used across different nodes. Let's talk about nodes talking to each other, nodes of the fabric. So this is IO Fabric 1, and then you have this other box, and this is IO Fabric 2, and then you have this tiny little box, and this is IO Fabric 3, because this is like the Raspberry Pi or something, mobile that runs Linux. So you have a fabric controller, and all of them can see the fabric controller. This is a requirement of the fabrics before they go into offline mode. Any IO Fabric installation can run offline if you so choose to sever the connection. And you say, okay, I'm going to get this thing ready, and then I'm going to break it, and I'm going to take it, and I'm going to put it in a truck, and we're going to drive this thing cross country, and it's going to do edge processing for me as I set it up to do. That's great, and it talks to all these little sensors that are in its local environment. Go ahead and do that. We'll segment that off from the fabric at one point, and it goes off and it does its thing. It had to have gotten its instructions from the controller, though, at some point. A requirement of getting an IO Fabric running is that it can see a fabric controller. Within the summer of 2016, the IO Fabric controller will be distributed the same way that the IO Fabric agent is. You'll be able to put the controller wherever you prefer. But anyway, so it has to have been able to see it at some point, because if it couldn't, then how on earth could it get instructions? This is common sense. The other fabrics, let's say you leave them connected, and then these ones are talking to the fabric controller constantly, meaning that you can just go ahead and dynamically change them. They never went into offline mode. Good for them. Okay, but I have a process here, process J, which is a microservice, and I really want it to talk to process K over here on this IO Fabric. So if I see one more bit of code that has J running a special thread that talks to some cloud that then K pulls it down. If I see one more bit of that, I'm going to blow my top, because this is completely wasteful. With IOTRACKS, you get this internetworking absolutely for free. So J decides that it wants to pass a message over to K, pass some data, and maybe the J is a camera and it wants to send this a picture that it's seeing over here and wants to send it over to here for some image recognition. And this is a tiny processor, so you don't do image recognition there. You do it on the LAN over at this box. So the IO Fabric agent has the ability to take instruction from the fabric controller that involves that gets it to do some networking via. So these are these are TLS pipes, little single-use TLS pipes, and it can send the information over from here to here, from J to K, without you having to write any code. And I'll show you the interface for setting this up, which is called IO authoring, and you can use any interface as long as you can program the controller. But so you should never, ever, ever have to write this type of code again, and it can be bidirectional. And in addition, this internetworking can happen between a couple of fabrics that are on an edge, a particular edge, and they all talk to this fabric controller. And they can also talk to anywhere that the cloud can reach. So let's say instead of this fabric controller being here on the edge, there we go, pretty good job of erasing lines, we have them all talk to a fabric controller that is visible from behind different NATed networks and so on. So completely separate private deploys, networks across the globe, all capable of seeing each other because of the next technology in the IOTRACKS architecture that I want to illustrate, which is called ComSat. So I guess you are going to get a little like space illustration here from me. It's not a great cartoon, but let's just say that this is a satellite. So ComSat is distributed technology that you put wherever you want to have a common viewpoint. I gave a presentation at Amazon Loft about this, AWS Loft about this. It's called the edge of the cloud. So you can just go YouTube look at that. And if you want to hear more about the edge of the cloud. But so this is Fabric 1 and this is Fabric 2. And how on earth do these things communicate? Well, so the ComSat serves as a TLS, a private TLS pipe facilitator. A lot of folks think that VPNs are going to solve the connectivity issue that you find between netted networks, and so on. And while VPNs solve that for like work groups accessing, network resources such as drives or intranet resources, it doesn't work for IoT. There's a lot of reasons why not, but some of them being that you have to set it up, and then you have to have VPN facilitation that exists on a common point that everything can see. You also have to have resources to stand it up, and in addition, it exposes an entire network, and what you really want to do is you want to have some little pipe open. So the Fabric controller tells F1 that it's going to start passing stuff over to F2, and this little process gets instantiated here, which is also a container. That means it can improve over time. And this thing says, okay, I don't know anything about F2, nor should I. I'm going to talk to this thing that I know and trust called the ComSat, because I have a security certificate here that lets me know if the ComSat is legit. This is all distributed, so you've put the ComSat where it is convenient for your deploy, and you've put the certificate on the fabrics, right? So FIO Fabric number 2 does the same thing. Both of them independently contact the ComSat and verify its identity, and then they open, when they have verified, they open their side of the TLS pipe. So what that means is the TLS pipe is then privatized, and the communication happens in encrypted fashion between the two of them. But neither side understands where the other side is and how to reach it, because both of them only talk to the trusted source. Now let's say that IOFabric 2 goes offline. IOFabric 1 then can optionally pull back its connection and say, I see the other side has gone off, I don't want to talk either. Or IOFabric 1 can say, I will just stay here and wait. So let's say this was a connectivity glitch. IOFabric 2 then says, here, I'm back. Then immediately the private pipe between them, it's a new pipe, but it's transparent to them which pipe they're using. It's just back. It reappears. Reattaching is a piece of cake. Note that the reattaching did not require any handshaking from the other side. The reattaching involved, in this case, IOFabric 1 is waiting and says, I'm good, I'll stay online. I know that this I still see the trusted source, and it's still trusted, and its identity checks out. When IOFabric 2 comes back online, it establishes a connection to a known entity, just like it did at the start, and the data begins to flow again. This is very different than IOFabric 2 knowing that IOFabric 1 exists, trying to find it, handshaking to make sure that it's still the IOFabric 1 that it said it was, etc. So, other advantages of this. So what this gives you is these are IOFabrics, and this is the whole planet, and you get this, and you get this for free. And you write microservice A, and then you want A to talk to B, and then C, and then you're using A here and here and here. And this is what is the open source fog computing that you're getting, right? So just to make that absolutely clear how that all goes. And you did nothing to interconnect those, nor should you ever. Here's another advantage of ComSat, and then I'll show you some IO authoring, and I think then we're going to wrap this video up. So here's another IO fabric, and this is F3. And you have out here, this is a regular desktop computer. And you have some data that you have here. You've been talking to the sensor, and then let's say that it's this process R, microservice R that you've created on the fabric. Well, I'm not going to draw the whole there you go. That's a ComSat now. That's what you get. So cool. So you've got all this important information here. You would love to be able to tap into that information, but this is behind a netted network. So meaning it's private, and it should be private, because if you put raw compute and sensor, things talking to sensors, you put them on the public internet for accessibility, you get a lot of problems there. So what you'd rather do is you'd rather keep this private, but then you wish that you could reach it, and you're over here and you're in, let's say you're in New York, right? And this thing is in Dallas. You'd love to see that data. Okay, well, using ComSat, there's another side of ComSat where the fabric can say, hey, ComSat, I want to verify you. Okay, now we're attached, but I'd love you to open something out to the public, which we call a public port, and anybody can access it. Now you can put a key code on it if you want, so there's some security layers you can put in to make it so that not anybody can look at it, or you can leave it open for anybody to look at it, and you get a single port, and let's say this is port 80 that you want to talk to inside your R microservice. So I wish I could talk to port 80 inside that container running on a Raspberry Pi in Dallas, Texas, from New York or anywhere, so I can see the data without having to do any kind of network programming and cloud storage and so on. Wouldn't that be great? Yeah, you do it. And when you open the public port, then your web browser says, hey, I wish, and you've got a URL here that's something like, comsat7.iotracks.com, whatever. That's because our comsats are deployed for you. We have a bunch of comsats running that you can just start using. You can make your own, put your own comsat on your own servers and so on, and then it can be abccorp.com, and then that's how you would make it so that you could have your own hosted access to resources. You do whatever you want. And you don't even have to have domains. You can just be IP addresses. So this browser says, hey, give me the data. Then, without any idea where this thing is, you all of a sudden find yourself talking to port 80 inside microservice R, which replies back to you, and it routes back around, and you get the exact byte results that you would get if R, it's like, here's the ghost version. Ooh, it's a ghost. R is up in the cloud, and you could just talk to it. But if it was up in the cloud, it couldn't talk to a sensor. I don't know of anybody who has 1,000 sensors that are all sitting out on public internet so that they can talk to some server so that they can access that server. This situation is ridiculous. So what this is akin to is if you want to call your mother right now, and you are here, and you're in San Francisco, and then she's in Chicago. If you want to talk to her, you don't tell your mother, hey, go down to the telephone company where I can reach you. It's a little old school. You just call her, and you get a line to your mother. If she picks up, you get to talk to her. You don't send her to some publicly accessible place so that you can reach her. Taking data from devices and putting it directly to a cloud so that you can access it, that is the equivalent of putting your mother down at the telephone company so that you can call her. Let's do better than that. Let's use ComSat or something similar. That's why it's open source. And take and keep everything that you need to keep on the edge. Keep it there and still be able to access it. That is the point. And now, as you can well imagine, this will probably disrupt a whole lot of cloud storage situations. That's the point. I'm looking forward to it. All right, so let's take a look at what you get in the situation here for IO authoring for controlling everything. All right, so here's something that you might have constructed. I have it's Hackathon 1. That's the current track I'm on. Yeah, let's just use Hackathon 1. So a track is not only the namesake of the IOTRACKS here, but there's a reason why. A track is the thing that you use in order to organize the different microservices and connect them and so on. So microservices are accessible here and in the catalog form, and you can just drag and drop and create. And this is how you instantiate a microservice on a fabric. Then you say, I'm going to run it on this fabric here. Done, it's already running. Okay, where do these fabrics come from? You manage your fabrics here, and I'm going to create a new ARM Linux fabric, and then great, and then I'm going to match it with something I installed, and I generate provisioning key. Okay, great. I just use this key and the command IOFabric provision followed by this key, and it will all of a sudden become this fabric node that I put on here, number called ABC. It will all of a sudden become ABC, and then when I go and I build stuff and I say I want to run this on ABC, I do that, and now that's running on that piece of the fabric, that node that I selected there. Also, creating microservices, you just go and say, I'm going to create a new microservice that runs on ARM, and then you say, go Docker, and you give it a name, and you say this is, fun micro service 1, and misspelled, but who cares? It's a little video. And then you can give it an image, and then oh, sorry, that's the container image, meaning that's the identifier. So you can go ahead and you can pick files, right? So that's how you go and upload a picture for it, and then it becomes available in the catalog. Well, what you publish there becomes available to your catalog for your organization, you and whatever users you're working with. If you make something great, we'll promote it up to the top level, and it will become part of the third-party catalog that the whole world can use. This is the IO authoring tool that allows you to control the fabric controllers, and that's how you actually work with the fabric. And note that what you might want to do at the end is you might decide that in the end you'd love to push all of the information into, let's say, where did Salesforce go for me? Why is that not? There it is. You decide that in the end you want to put it into like force.com. So then you take that, you patch that over, and now you have, and then you do your configuration for it, and then now you have an output that goes into some back-end platform that you already have in place. And this is your way of actually making, remember that initial diagram, making use of that fog compute layer to talk to myriad end situations that make use of the data. Backend platform, expose a REST API so that you can program against it with mobile apps, do whatever you want with it. And you did all this great processing in the meantime. Maybe you did some sub-selection, you did some sourcing, maybe you decide that you do some machine learning, maybe you connect to some stuff that's via Sigfox and so on. All microservices oriented. The reason being, if we were going to get the Internet of Things right on the first try, then I guess it would be okay to have an end-to-end quote-unquote platform that allowed you to write in a particular language, and then you flashed some compute with it and deployed it, and everything was golden. Last I checked, we were still shaking out a ton of stuff on the Internet of Things architecture, and devices were growing and changing rapidly. So probably better to encapsulate all software as microservices, deploy it dynamically to the edge compute, change it out as needed in order to get it right, and speak whatever you need to speak between these, which is just open bytes with a MIME type on it, the same way that the Internet grew and changed at the start. If we had 25 MIME types at the start of the Internet and we said, that's it, that's all you get, you got to work with those, we would have never, ever done what we did. So now for the Internet of Things, instead of saying, here's the 15 protocols that are officially supported and here's the data formats that they all can carry, instead of doing that, we should probably leave it open so that you can do whatever you want between your code, write that code in any language, and then wrap it in a MIME type that you define dynamically so that you and your team can get stuff done, and then put that compute wherever you need to put it so that you can talk to the things that you determine to be important for your solution, all dynamically because you didn't know at the time that you started building the solution, you didn't know every little detail, and that's appropriate. So I think that's about it for the video. I hope this explains things. Have a good one.